Hey guys, welcome back to another Rust tutorial. In this video we'll be talking about enums and pattern matching. You've probably heard of enums in other languages such as Java, but Rust enums behaves more like enums in functional languages. Let's take a look. To declare an enum, we simply use the enum keyword, followed by the enum that we want to create. Let's make an enum that tells us if an IP address is version 4 or version 6. Now let's make a struct that contains an IP address. And now we can instantiate one of our structs. We can also enable debug printing for our enum. After we do that, we can now enable debug printing for our struct as well. So let's print out our struct. And we can see we got our struct printed out. And the enum is version 4, and we have an address. We can also make another address with version 6. And now we have an address of type version 6. This is pretty similar to how you would use an enum in other programming languages such as Java, but Rust allows us to do something different. We can actually associate fields to our enums. Say for version 4, we can have 4 unsigned 8-bit integers associated with it. And for version 6, we would have a string associated with it. This way we don't need the extraneous struct, and we can just write it like this. Now we can change our enum to just be an IP address rather than the kind of an IP address. We can run it again. And now we can see we get our version 4 and our version 6. We can also have named fields. Let's say we have a version 7 and it has an X value and a Y value. So we can have a third address. Like this. We can print it out. And now we have X and Y. Okay, now that we have values to our enums, how do we actually access them? To access the values in an enum, we will need to use pattern matching. So what is pattern matching? Pattern matching is a different way of expressing your logic. In a traditional approach, say we have some sort of struct with 3 fields inside of them, A, B, and C, and we want to make sure that A is a specific value and C is a specific value. In this case, we want A to be equal to 10, and we want C equal to 16, then we do something. But this kind of approach is kind of error prone, especially if your structure or whatever you're dealing with contains a lot of fields and you have a lot of complex logic. So what pattern matching allows us to do is, rather than explicitly stating each condition that we want, we can simply say, here's the struct that we want, and here's the struct that we have. You put them together and see if they make a match. In this case, what we want is A equal to 10. We don't care about the value of B, and we want C equal to 16. And what we have is A equals to 10, B equals to 12, and C equals to 16. If we overlay them as a pattern, we see that A and C are a match, and B we don't care about, so it is also a match. This way our code is much more expressive and easier to read and understand. So let's take a look at how Rust does this. To use pattern matching, we use the match keyword, followed by the value that we want to match on. Then we have open brackets. Inside these brackets, we state all the different values this variable can contain. Our enum can contain 3 values, a v4, a v6, and a v7. But these variants also contain values associated with them. With v4, we have 4 u8s. With v6, we have a string, and with v7, we have 2 unsigned 32-bit integers x and y. So we would need to add those in as well. With v4, we can assign the 4 u8 fields as 4 different variables, a, b, c, and d. Through a, b, c, and d, we can now access the values inside our enum. Let's print them out. The same can be done with v6 and v7. We can also have multi-line statements using the curly brackets. And let's print out the sum of x and y. And we can see we print out our v4 IP address. So there are only 3 variants to our enum, but our variants can contain many different values, so we can have more than 3 patterns. Let's say we want to print localhost whenever a IPv4 with the values 127.0.0.1 is given. We can create a new pattern with all the values that we want hard-coded inside it. And now Rust will print out localhost whenever we have a version 4 IP address with values 127.0.0.1. One thing to note is the patterns are evaluated from top to bottom. Rust will execute the first pattern it matches with and disregard all the rest. So we'll check the first condition first and see if it's satisfied before going on to the next, and the next, and the next. Finally, Rust match statements requires you to cover all cases. So in this case, we covered v4, v6, and v7. But if we take out, say, v7, we would get an error. But sometimes our values can have a wide range of values. Then we can use the underscore placeholder to cover all other cases in a match statement. Say in this case, if we don't know what a v7 IP address is, and we try to put in a v7, it would go to the last case and say we don't know what this is. Another thing is, if we only care about certain values, say we only want to make sure that the version 4 starts with 127 and ends with 1. Then we can use underscores as placeholders, meaning we don't care what the value is. We just want to make sure that the first and last value are these. Of course, we can also use just variables here. Finally, we can also use pattern matching with if statements. Say we only want to check one particular case. If our address 1 is version 4, we would write it like this. Then we would print out localhost. And this will just cover one single case. Rust also provides some enums of its own. One of them that's used very often is the option enum. Now you might have noticed that we never talked about null values in Rust. That's because there is no concept of null in Rust. However, there is an enum type that represents the absence of a value. And that enum is called option. It has 2 variants. It either contains something with the some variant, or it contains nothing with the none variant. Let's say we have a number, option U32, and we can either say it's sum 5, so it's going to have some value 5, but it might not actually have a value. We use a match statement. And if we changed our value to not contain any value by the none type, we will see that we get no value. This is a really great way of avoiding null pointer references. This way, we must use pattern matching to make sure that there is a value contained in this variable, rather than just a null variable. Okay, that's it for this video. Leave a like if you found the content useful. Subscribe if you want to see more content like this, and I'll see you guys in the next video.